This lesson will cover the following topics: passive safety and active safety, pyrotechnic systems, methods of restraint. Passive safety is all the devices fitted inside a vehicle to protect the occupants during a collision. Passive safety consists of the following components: the airbags, the seatbelt pretensioners, the crumple zones in the vehicle bodywork, and the passenger compartment structural reinforcements. Now let's take a look at the difference between passive safety and active safety. Passive safety consists of the components designed to protect the occupants inside the passenger compartment during a collision. Active safety consists of the systems which contribute towards the prevention of an accident. Active safety consists of the following components: the ABS and electronic stability program, intelligent screen wipers, the voice synthesizer, xenon headlamps, or cornering lights. When a moving vehicle is subjected to a frontal impact, it undergoes a high rate of deceleration. The vehicle comes to a stop in a fraction of a second. The occupants are also subjected to this deceleration. The force of the deceleration varies depending on the speed. According to the laws of physics applied to a moving mass, if the speed of a body is doubled, the force of the deceleration during an impact is quadrupled. The impact absorbed by the occupant of a vehicle during a collision is comparable to falling from the top of a building. An impact at 40 miles per hour, 65 kilometers per hour, is equivalent to falling from a 15-meter building. An impact at 80 miles per hour, 130 kilometers per hour, is equivalent to falling from a 60-meter building. If the speed coefficient is doubled, the force of the impact is quadrupled. A vehicle which protects its occupants must, above all, crumple to absorb the deceleration force of the impact. During an impact against a concrete wall, a tank does not crumple, but its occupants receive a fatal deceleration force. The occupants of a modern vehicle subjected to the same type of impact have a much greater chance of survival, as the front section of the vehicle is designed to absorb the deceleration force. Let's look at the changes that have taken place in the protection of the vehicle occupants. In the past, vehicles offered no protection, and the occupants were hurled against the dashboard during an impact. Seat belts made their appearance, but because the front of the vehicles were very rigid, the impact received was always very severe. The front structure of vehicles is now equipped with crumple zones to absorb the impact. The rigidity of the passenger compartment, combined with the crumple zones and the addition of a programmed restraint system, PRS, reduces the impact experienced by the occupants. Depending on the position of the impact, different force paths are used over the vehicle structure. The vehicle has 3 force paths: a low-level path comprising the radiator support crossmember and the engine subframe, a medium-level path comprising the front side member, and an upper-level path comprising the scuttle panel and its stiffener. These different force paths allow the maximum amount of energy to be dissipated during a frontal impact, regardless of its impact area. The front structure is designed to absorb different levels of impact. Impacts are classified according to their severity. The least severe impact, involving just the impact crossmember and the front end panel. Severe impacts, involving the crumpling of the front section of the side members. Very severe impacts, involving the controlled crumpling of all of the front end unit structural components. During an impact, the passenger compartment must remain rigid to provide the occupants with a survival cell. The main passenger compartment strengthening components are the following: the dashboard beam, the side door reinforcements and lateral supports, and the floor reinforcements. The passenger compartment must limit the amount of intrusion and prevent bodywork or mechanical components from coming into contact with the occupant. The main components which limit intrusion are the following: the bonnet hinge retaining hooks, the retractable steering column, the retractable pedal assembly, the chamfered edge of the master cylinder. During an impact, two factors cause the injuries received by the vehicle occupants. Firstly, the deceleration experienced by the occupants, and secondly, the crumpling of the passenger compartment and the intrusion of mechanical components or structural elements. To make a vehicle safer, the following conditions must be respected: to promote crumpling of the front section to absorb the maximum amount of energy whilst preserving the passenger compartment, to limit the risk of injuries received by deceleration using methods of restraint. Contrary to a frontal impact, during a side impact, the occupants are located in the immediate proximity of the point of impact. The structure of the vehicle incorporates steels known as very high tensile, VHTS, and ultra high tensile, UHTS. These materials absorb more energy during deformation, thereby increasing occupant safety. These panels absorb more energy as they crumple. The B-pillar, combined with the reinforcements and the absorption components, padding, located inside the doors, contribute towards the reduction of the energy transmitted to the occupants. The programmed crumpling of these components lowers the impact experienced by the occupants and reduces the risk of injury. The layout of the passenger compartment is designed to limit the risks of injury. The shape, the location and the component material are designed to assist in the protection of the occupants. Removal of the ignition switch and the retraction of the pedal assembly during an impact limit the risks of injury to the lower limbs. The padding and the shape of the dashboard make this component less dangerous for the occupants. Lastly, the absorption components, padding, located inside the dashboard, the floor carpet or the side doors, limit and control the forces against the occupants. The restraint devices are identified by inscriptions found in the bottom corners of the windscreen and inside the passenger compartment. The word airbag can be found on one of the following components: the center section of the steering wheel, the passenger side of the dashboard, the seat back of seats fitted with a thorax airbag, or even on the passenger compartment interior trim for the curtain airbags. In this section we covered the following points. Passive safety is all the devices fitted inside a vehicle to protect the occupants during a collision. A vehicle which protects its occupants must, above all, crumple to absorb the deceleration force of the impact. The rigidity of the passenger compartment, combined with the crumple zones and the addition of a programmed restraint system, PRS, reduces the impact experienced by the occupants. The restraint devices are identified by inscriptions found in the bottom corners of the windscreen and inside the passenger compartment. For deployment during an impact, the airbags use a pyrotechnic system. The pyrotechnic system comprises an electric ignition module and a gas generator containing a solid propellant. The passive safety system comprises the following components: a computer, front and side impact sensors, pyrotechnic ignition modules with their gas generator, and a warning light on the instrument panel. The airbag computer analyzes the vehicle rate of deceleration using its sensors in order to determine whether or not the severity of the impact requires deployment of the airbags. The airbag computer incorporates the front impact sensors. The airbag computer is located in the center line of the vehicle, in the majority of cases underneath the center console. If the pyrotechnic system should fail, The airbag computer switches on a warning light on the instrument panel to warn the driver. There are two generations of computers. The first generation computers do not have the diagnostic function and cannot be checked using clip. The XR-bag test kit is required to diagnose the first generation type systems. The second generation computers have the diagnostic function and can be checked using clip. The computers are able to manage the airbags and seatbelt pretensioners separately or in conjunction with each other. The computers control the lateral airbags using special impact sensors. The computer power supply is provided by the vehicle battery. However, a reserve of energy is included inside the computer in case of battery failure during a collision. Self-contained driver's airbags include the airbag cushion, the computer, and the electrical supply. The computer is electrically supplied by a set of batteries. When the main battery comes to the end of its life, a secondary battery supplies the relay for a period of 5 weeks. A warning light on the steering wheel flashes to warn the driver. This warning light is also used to warn the driver of a potential system failure. The batteries must be replaced every 4 years. The impact sensors are accelerometers which measure the severity of the impact and inform the computer. The front impact sensors are built into the computer. The side impact sensors are located on the left-hand and right-hand B-pillars. During a frontal impact, the steering wheel airbag is deployed to protect the driver's head and thorax. The dashboard airbag is deployed to protect the front passenger. During a side impact, the lateral airbags are deployed to protect the occupants sitting on the impact side. Deployment of the frontal and lateral airbags depends on the severity and the location of the impact. A warning light located on the instrument panel informs the driver of a fault. When the engine is started, the warning light comes on for a few seconds while the computer checks the electrical circuits and the pyrotechnic ignition modules. Caution: a warning light that is on does not mean that the whole system is deactivated. Only the lines with a fault are deactivated, the others remain active. The pyrotechnic ignition module triggers the combustion to deploy an airbag. The pyrotechnic ignition module contains a filament encased in the propellant. When the electrical signal from the computer crosses the filament, the propellant ignites instantaneously. Combustion of the propellant generates the gases needed to inflate the airbag. Before checking a gas generator, you must consult the safety recommendations contained in the technical documentation. The seatbelt pretensioner reduces movement of the occupant by holding him or her against the seatback prior to deployment of the airbag. The lap pretensioner limits any sliding by holding the occupant against the seat base. The pretensioners are controlled by the airbag computer depending on the severity of the impact. An airbag lowers the impact experienced by the occupants during an impact. Its action is in addition to the seatbelt. When an airbag is ignited, the generator supplies the quantity of gas required for its deployment. The gas generator is controlled by the computer. Ignition takes place approximately 15 milliseconds after the start of the impact. The airbag then takes 30 milliseconds to deploy. When carrying out an operation on a pyrotechnic system, the safety instructions must be adhered to in order to prevent any accidental triggering of a pyrotechnic component. Any operation on a pyrotechnic system must be carried out by qualified personnel. The airbags have a pyrotechnic gas generator, an ignition module, and an airbag, which under no circumstances must be separated. All operations on the pyrotechnic trigger lines are prohibited. It is essential that pyrotechnic systems comprising pretensioners and airbags are checked using the diagnostic tool. When carrying out an operation underneath the vehicle body, it is essential to lock the airbag computer using the diagnostic tool and to switch off the ignition. The battery must be disconnected when replacing a pyrotechnic component. In this section, we covered the following points. For deployment during an impact, the airbags use a pyrotechnic system. The passive safety system comprises a computer, impact sensors, pyrotechnic ignition modules with gas generators, and a warning light on the instrument panel. The airbag computer analyzes the vehicle rate of deceleration using its sensors in order to determine whether or not the severity of the impact requires deployment of the airbags. The impact sensors are accelerometers which measure the severity of the impact and inform the computer. The seatbelt buckle pretensioner reduces movement of the occupant by holding him or her against the seatback prior to deployment of the airbag. When carrying out an operation on a pyrotechnic system, the safety instructions must be adhered to in order to prevent any accidental triggering of a pyrotechnic component. A vehicle equipped with passive safety comprises several restraint devices to guarantee the safety of its occupants. These are the airbags and the seatbelt pretensioners. The frontal airbags are triggered 15 milliseconds after the start of the impact and take 30 milliseconds to deploy. These frontal airbags protect the head and thorax of the front seat occupants. Some airbags are double volume airbags and have two independent pyrotechnic ignition modules controlled by two separate trigger lines. Full or partial deployment of the airbag is determined by the severity of the impact and by the position of the seat. If the seat is in the fully forward position, the airbag deploys using an airbag volume just sufficient for the size of the occupant. The adaptive frontal airbags have two compartments connected together by a rip seam. The large volume airbag is obtained by the tearing of this seam when the second pyrotechnic generator is ignited. Adaptive airbags also have a device which is used to regulate their pressure. Vents open up if the airbag pressure becomes too great following contact by the occupant. The lateral airbags protect both the head and thorax or just the thorax, depending on the vehicle type. These airbags are fitted to the door side of the seatback frame of the front and rear seats. The lateral airbags are controlled by the computer. A special sensor fitted to each B-pillar informs the computer of the severity of the impact. The self-contained lateral airbags are not connected to the vehicle airbag computer. Self-contained lateral airbags are completely independent and operate of their own accord. The impact sensor and the pyrotechnic ignition module are built into the airbag. Self-contained airbags may be triggered even if the main computer is locked. You must consult the technical documentation before carrying out any operation on an airbag system. On certain vehicles, protection of the occupants' heads is provided by the curtain airbags. The curtain airbags are fitted into the upper corners of the vehicle roof panel. The curtain airbags are deployed in the event of a side impact. Only the airbag on the side of the impact is triggered. The curtain airbag is triggered at the same time as the lateral airbags. Curtain airbags are connected to the main airbag computer. A switch located on the driver's seat runner adapts the deployment of the steering wheel airbag to the position of the occupant. The switch detects the position of the seat and sends a signal to the computer. If the seat is positioned well back, the airbag is fully deployed. If the seat is positioned further forward, the airbag is partially deployed. The rotary switch provides the electrical connection between the computer and the airbag located in the steering wheel. The rotary switch comprises a tape with conductor tracks, the length of which is designed to allow for 2.5 turns of the steering wheel for each direction. Any operation on the steering system involves aligning the rotary switch to its center point. You must consult the technical documentation when carrying out an operation on this component. During an impact, the seatbelt buckle pretensioners tighten the seatbelts before the airbags are deployed in order to hold the occupants in their seats. The pretensioners are activated approximately 12 milliseconds after the start of the impact. Various seatbelt pretensioner configurations exist depending on the vehicle model. The seatbelt pretensioners for the front seats are of two types: with a cable or with gears. They are fixed to the seat frame or to the passenger compartment B-pillar. The pretensioners for the rear seats have Pyrotechnic inertia reels. These pretensioners are built into the seatbelt retractor and use a ball bearing system with a pretensioning ring gear. When the gas generator is ignited, the balls are expelled, activating the pretensioning ring gear, which tightens the belt. The force limiters reduce the stress applied to the thorax and the pelvis by partially releasing the seatbelt during an impact. The force limiter components work if the tension applied by the belt becomes too great. Let's take a look at the different types of force limiter. The force limiter metal mounting bracket tears to allow the inertia reel to rise and to release the belt. The force limiter built into the inertia reel, LEI, has a torsion bar which crumples and twists to allow the belt to unwind on the inertia reel. The force limiter contained inside the lap belt pretensioner has a spiral rod which twists to allow the belt to be released. The reserve belt force limiter has a rip seam which tears when pulled. The deactivation switch deactivates the passenger front seat Pyrotechnic components to allow a child seat to be fitted. The computer deactivates the trigger lines concerned: the passenger frontal airbag lines, the passenger thorax airbag lines, and the passenger lap belt pretensioner. In the on position, all the system components are in operation. In the off position, the components concerned are deactivated. A warning light on the instrument panel indicates whether or not the passenger airbag is deactivated. During an impact, the occupant's pelvis is subjected to the slip or submarining effect. The force of deceleration created at the point of impact moves the occupant's pelvis forward, thus causing it to slip under the lap belt. The following components reduce the slip or submarining effect: an airbag cushion in the front seat base on 3-door versions, a hump in the floor panel underneath the rear seats, and a lap belt pretensioner. The head restraint reduces neck injuries caused during a rear impact. During an impact, the head is flung backwards, and this can cause serious injury. The head restraints limit the movement of the head. For optimum effectiveness, the top of the head restraint must be adjusted as close as possible to the top of the head. Some head restraints unfold to support a child's head when seated in a child seat. The ISOFIX system is a system adopted by the motor industry to standardize the fixing points for child seats. The majority of vehicles have been equipped with this rear and front passenger seat fixing system for a number of years. When a child seat is fitted to the front passenger seat, it is very important to deactivate the pyrotechnic components using the deactivation switch. The seatbelt inertia reels allow the seatbelt to unwind freely. Two situations cause the seatbelt inertia reels to lock. The seatbelt unwinding speed exceeds a certain acceleration threshold. The vehicle's acceleration and deceleration together with its angular position. For comfort, the front seatback may incorporate the inertia reels. These inertia reels have an electrically controlled lock and operate independently via an optical sensor. During an impact, it is the airbag computer which controls the locking of the inertia reels. The cabriolet versions are equipped with retractable protective arches. These arches protect the occupants if the vehicle should overturn. A roll angle sensor detects the vehicle movement and sends the command to the computer to activate the protective arches. The activation of the protective arches is managed by a computer located behind the rear bench seat. The computer has 3 sensors. A lateral roll angle sensor to activate the arches if the vehicle should overturn. A front and rear longitudinal angle sensor to activate the arches during a front overturn. And a free fall sensor to trigger the protective arches if the vehicle should experience a drop. If there is a loss of electrical power, the computer has a 5-second energy reserve to deploy the protective arches. The computer is connected to the roof control unit in case of a fault. At the time of activation, the computer powers a solenoid valve which releases the retractable protective arches. In this section, we covered the following points. The adaptive frontal airbags have 2 compartments connected by a rip seam. The lateral airbags protect both the head and thorax, or just the thorax depending on the vehicle type. The self-contained lateral airbags are not connected to the vehicle airbag computer. On certain vehicles, protection of the occupants' heads is provided by the curtain airbags. During an impact, the seatbelt buckle pretensioners tighten the seatbelts before the airbags are deployed in order to hold the occupants in their seats. The force limiters reduce the stress applied to the thorax and the pelvis by partially releasing the seatbelt during an impact. The deactivation switch deactivates the passenger front seat pyrotechnic components to allow a child seat to be fitted.